So let's look at this first question. So again, it's similar to this is this exam was about integration. It was going to be a mixture of ideas. The first thing you had to realize was that you had an x squared and an x here. That this looked sort of messy, and so you really needed to do a substitution. That wasn't worth very much, but this was the key. Now the actual problem was, do you know how to integrate such a thing like this? And we don't give much partial credit if you have no idea. So you really had to know the strategy is you're trying to set up a substitution. How do you set up a substitution? Well, when we're talking about secant and tangent, there was only two possibilities. And you could put this on your note sheet. We had a table of here's what you do if it's even, here's what you do if it's odd. So this is preventable errors if you didn't know what to do here. That's why it's a bigger deduction if you had it wrong. So these were the two possibilities. So your step one was either to pull this out or to pull this out. That should have been the very first thing that happened. And so if I did not see this pulled out or this pulled out as the first step, then you're going to lose most of the points. Because you got to show me that understanding. Okay, so if it's even, it works out best to pull out a secant squared. This one doesn't work very well because it's going to leave a secant squared. So you're going to have a secant squared and a secant squared. I'm just adding a few more details. And then the point was to turn everything else into a tangent so that you can use this substitution. That was the big idea of the section. And the way we do that is we have that identity. Hopefully you had that on your note sheet. I noticed a few people had the wrong identities on there. But then this becomes u squared plus 1 du. So the entire thing is to set this thing up so you can do the substitution, then you can integrate, and then you just have to remember to replace. Various people made small mistakes. I scrolled through that, and really the vast majority of people got that completely right. There was a certain percentage that had some sort of error with their constants or an integration or something, and they lost a point or two. And then there was this collection of about 20% of the class that had no idea what to do. So to me, that's something we had to be prepared for. If you want to leave this course, you got to know the techniques. Okay. Then we had a partial fractions problem. This is probably one of the easier questions on the test based off of performance because almost everybody got this right. People that lost large chunks of points either didn't know this, and to me that's kind of inexcusable. You do need to know the partial fraction stuff we discussed. We had a whole section on it. We had a worksheet on it. So anyways, we got to know the stuff to do it. A few people forgot the general form. If you only write a over x squared, it's not possible to make these two sides equal. You say, well, I found numbers, but go ahead and expand what you got. They're not equal. Some people are not doing the most efficient thing. So the most efficient thing is to plug in something that makes most things 0. And one of them is 0. If you plug in 0 everywhere, you end up with just b times 3. I went through and noticed that our grader, one of your TAs, was probably too lenient here because I really wanted him to take off a point for every one of these was wrong. And I noticed some people, in some cases, he just took off 1 for a small mistake. But honestly, these were checkable things, so I didn't change it. I went with what your grader did because they were consistent. But to me, there's not much of an excuse. You need that these should have been right because we can get them so quickly. I guess maybe you mess up some arithmetic here, but still. And then the fastest way to find the other one is to look at the coefficients. If you were to expand this out, you're going to get ax squared plus 3. And we talked about this in class. Plus bx plus 3b. And this is an important idea for future courses. So that's part of why I said it is if you look at the x squareds, on this side there's an a plus c. Then you go look at the other side, what's the number in front of x squared? It's 1. That was really all I needed. So you can see in my solutions I stopped there because I was trying to find a. But you could keep going. You could say, well, 3a plus b, these coefficients have to add up to negative 2. That's a coefficient on the other side. And lastly, 3b, which is the constant coefficient, has to be 12, which is good because that means b is 4, which is consistent. So there were several ways to sort of check your work as you went. One thing you could do if this is the final exam and you're prone to errors is just replace the 3 numbers here with the numbers you found, expand it out, and make sure that this ends up being the same as this. So as you think about the final and the fact that you'll have more time, make notes to yourself of, hey, here's a place where I could check my work and be certain I'm right. Then we had to integrate. And most people did this right. I noticed that there was a handful of people, maybe 5% of the class, that integrated this wrong. It's actually a dramatic error to say this. This is not right. We talked about that in class. This is actually, apologies that came up. This is actually 4x to the negative 2. That's what this is. And if you integrate, the power should go up, and then you should divide by negative 1. That's what we should have here, which is what I wrote. I just wrote it in a nicer way. Okay, hopefully that kind of helps. I'll try to point out where common errors were. Of course, you can follow up with the question on the discussion board. This question is very much like many questions on the old exams. I actually did this one in class. And people did pretty well on this. I mean, you really had to know that if it was a product, a log, or an inverse trig, you're doing integration by parts. So to me, these first several problems, maybe you got confused on the x squared or something, but these are kind of direct examples of the main ideas. So if you don't know how to start something like this, then you go, oh, shoot, I'm just maybe not. Maybe I do need to take this course again in the future. Definitely if you're going to take courses that depend on this. Okay, so it's integration by parts. You have to pick this. I mean, some students seem to have not picked up on the lipid idea, and we're just kind of randomly guessing. Logs, inverse trig. And we said all this in class, power. So if you haven't been coming to class, that could be one issue. But we pick u to be higher. And in this case, the only thing we were given is an inverse trig. And so we're going to pick that to be u. So you had to know this is the derivative. Then you had to integrate 1, which was x. And then it's uv minus v du. It's this. And then you had to deal with how do you integrate this one. This wasn't too bad because it was a straight substitution. I mean, there were harder ways to do it. And some people did it harder ways. But there's an x squared on the bottom and there's an x on top. Regular substitution works and we're done. Technically, you don't need the absolute values here. Because x squared plus 1 is positive, but I give full credit either way. Okay, I don't think there's much to say there. Then we had a fairly standard trig sub problem. I'm sure I've asked that question almost identically in recent exams in the archive. I just wanted to see you could do straight trig sub. So you had to know 9 minus x squared. You're replacing x with 3 sine of theta. Why sine? Well, because sine has this nice identity that has a minus before the trig function that says this is cosine. So this is all about just plugging in. So first and foremost, don't forget to take the derivative. These sorts of exams are where people that are careless with these things really hurts them. And then the whole point, I always did this in the margins, was that the square root will simplify. Right? So the whole reason we substituted this in is that this is going to become 9 minus 9 sine squared. And then we can factor out the 9, which is why we picked a 3 here. And then we can write it as 9 cosine squared. And then ultimately, some people have trouble with this step, doing their algebra carefully. But this means square root and then cube. So it's the square root of 9. And this is not the first time. This is almost identical to a homework question. So if you were confused by this, the time to be confused by it was when you were doing it in the homework. And then you got to sort out those confusions. This is sort of the key to success. If you really want to study something in these areas, you got to figure it out as you're doing the homework. Okay, so that's what the denominator becomes. The numerator becomes 9 sine squared. I made it really nice so all the numbers cancel because you're going to get 27 over 27. And even one of the cosines cancels, so you have cosine squared over sine squared. Now, people integrated this in various ways, but once you realized you had sine squared over cosine squared, you should have been thinking tangent squared. There's other ways to go. There's identities you can use. There's many other correct approaches that get you to the answer. But ultimately, this integral came up, I think, twice in the homework. And that's part of what I'm thinking of these problems. I'm like, well, that's kind of tricky, except for the fact that they've seen it a couple times. this doesn't really fit any of our methods. And when that happens, you look for an identity. And the only identity we have on our sheet that involves tangent squared is secant squared minus 1. And luckily, those are integrals we know. Now, if you wrote the following, tangent of sine inverse, I talked a lot in class about how we were going to take off points if you left your answer here, because I wanted to see this skill. Part of my job is to make sure you know the skills of how to do this. So this lost points. So I know some people are going to ask for points back, but that was warned about lots of times, including on the cover of the exam. It says it in really large print. So if you left that there, that was your mistake for not preparing and reading the instructions. But again, the whole point of this was, how do we go from knowing that sine of theta is x over 3? I know WebAssign accepted some of these, but again, you had my very careful instructions of, you had to show me this. Okay, so you say opposite over hypotenuse, you solve for the other side, and then you try to figure out what tangent is, which is opposite over adjacent. You had to show that for full credit. All right, let's keep going. Sorry, where are we at? So then we have, as I promised, there would be somewhere on the test where you have to complete the square. I even said it probably would be here on this page. So anyways, half the middle is 3, which means the number I want here is 9. We're trying to make a perfect square. If you ever forget what perfect squares are like, you just run a little scenario where you expand a perfect square. It's half the middle squared. So then you say, well, if that's 9, what needs to be out here? So I'm not actually changing the function, and it's -4. Probably this will happen again on the final. So you take a moment, and on the final, if I was doing this on the final and I really needed to get a good grade, I would re-expand, and I would ask myself, is this the same as what I started with? Yes, it's the same. Good. So then the problem we were doing was the integral. This was just to get it in the form so we could start. X plus 3 squared minus 4 is the problem we're doing. Now it looks like a secant problem because it's a square with a minus afterwards. So we already did it earlier in this video, the problem where if it's a minus before, it's a sign. But in this case, we're going to try to make this identity appear, which is tangent squared of theta. So what do we need to plug in? We need to plug in 2 secant of theta into this spot. So the fastest way to do it is just to replace it immediately. You could take another moment. I mean, this is what I did in class, but you could take another moment and do a substitution, but this is the fastest way. Because that means this will become this, which will become 4 tangent squared, which will become 2 tangent. Okay, so the whole bottom becomes 2 tangent. Don't forget the derivative. The derivative of secant is 2 secant tangent. That's this. Tangents cancel. And this one's really nice. It's just the integral of secant. The integral of secant's in our table. Then once again, you're going to lose chunks of points if you did not do the triangle. That was very clear in my instructions and in class. I want to see that skill. So if you wrote, it's really bad to write this, secant of secant inverse. That ignores the fact that you already had the answer. So if you wrote this here, or you wrote tangent of secant inverse, again, I said this in class, I said it on the cover, but you lost points. You're going to lose a couple points for that because that's as part of the skills we were testing, was your ability to work with trig functions and give reasonable answers. Even if WebAssign would have accepted that, you had instructions to not do that on the test. Okay. Last one. This is kind of the challenge question, I thought. I thought students would struggle with this one the most. But I thought you had a fighting chance simply because you did the homework question that was the integral from 1 to 8 of 1 over x plus x to the 1/3. So this was mostly to reward people that had done the homework. If you did the homework, you would have known how to do this one. If you know how to do that one, in my mind, you also know how to do this one because it's the same problem. I just added one more thing in there. And the key idea you saw in that problem was to choose the substitution that was the root. And we talked in class how the cleanest way to deal with that is then to cube both sides. And you don't have to do this. You can take the derivative directly. You get 1/3 x to the negative 2/3 dx, and then you rearrange and you get dx is 3 x to the 2/3 dt. And that works. And at some point you would say, oh, that's the same thing as t squared, and that will get you there. But as we talked in class, for these sorts of substitution with roots, it's often easier to simplify first and then take the derivative. They both lead to the same place. But you had to somehow get this in here, so you couldn't forget this. The main difference between this and the homework question was the top is t. And the easiest way to do this problem is to change the bounds as you go. Okay, then you got here. Some people had trouble from there. That's not uncommon. I mean, at this moment, you should recognize it looks like a partial fraction problem, but it can be simplified, right? So you could do, first you could cancel a t. So we should be, at this moment, we should be thinking factoring, simplifying, partial fractions. So it should be running through that method. Is it reduced? What can we do? How can we factor? And first you could cancel a t, and then you get here. And you go, is it reduced? No, it's not reduced. So this is a division problem. I said somewhere on the test there would be a division. If we think back to, my cover page, or let's pull this up. Rules here. This might be an older document, but we had an updated one on my website. Yeah. I said you will have to complete the square. You will have to divide a polynomial. You will have to simplify trig and use the triangle trig. So many of you are getting the message, but there's still some that are not, about what does it mean to be prepared. Maybe you just don't have time this term. Maybe you should talk to an advisor. But anyways, so there we go. We get this, and then we could integrate. One small thing is this is a value we know. Look at the cover of the exam. On the cover of the exam, I tell you this value. But this is an example of simplifying well-known values of well-known functions. There is a small amount of credit we give for that. Okay, let's keep going. Question 4. This was a challenge. I knew this would be these two problems, the integral 3b and 4a, were in my mind definitely the most challenging integrals. It's interesting because people did this in all sorts of ways. This integral appeared on your worksheet. When we were in the partial fractions worksheet, this was in there. So you had to do this integral in quiz section in groups. So you spent considerable time doing this one a couple weeks ago. You did in quiz section, solutions were posted. So this was kind of to reward students that are faithfully going. I tried to do this. I tried to take homework questions. I try to take questions from worksheets and say, hey, we spent a big chunk of time here on this problem. So if you didn't know how to start, you sort of go, maybe just forgot. I don't know. But if there's a product, log, or inverse trig, you want to choose that as you. And I saw several people do this problem a different way. They did a substitution first and then did it, which also worked. But that's the case. I saw 2 or 3 people try to do the following, which I thought was clever, and one of those students did it successfully. So there's many ways forward. The hard part about this is, how do you fill this in? I don't know. So in my mind, the thinking is, I want to do integration by parts because there's a log. But there's actually 2 logs. And I saw a few mistakes where people didn't understand that squaring means something times itself. And that is not the same thing as the log of x squared. It is true that this simplifies. These are not the same. 2 times something is not the same as something squared. All right, so I think there was some mixing up of rules, which I sort of understand, except for the fact that this was a problem directly from the worksheets that we did. If you don't know what I'm talking about, I'm trying not to, I don't want to sound like I'm lying to you. Let's quickly look at this. Let's go to the Math 125 page. And let's see, this was when we did integration by parts here. So this is a problem we all did right here. This is it. So it was part of this question where you had to do a volume, but it was the integral from 1 to e of pi log of x squared. and you did this integration by parts. So that's where I pulled that from. All right. Anyways, the main difference here was average value, so you did have to divide by this. A few people messed up and did a substitution but messed up in their bounds. There were various computation mistakes, which did have deductions. There's various mistakes with this minus, common mistakes that happened that led to some deductions. But it was integration by parts, which led to this, and then you had to do integration by parts again. So however you did it, that was the problem. I don't think I'll go through all the details. But you do want to be careful. Remember that minus. All right. The region showed is bounded by these. So then we had this volume question. I said there would be one volume shells question, which was interesting. You know, one thing that was interesting about for some people is, even though I didn't explicitly say shells, you should have been thinking shells, because I had said I was only have a shell question. Some people tried to set it up another way. But let's recap one more time, because we need to know this for the final. If someone gives you a region like this, there is only one variable that makes any sense to use at all. What variable is that? The variable is x. The only variable that makes any sense to use here is x, because the entire region has the same top and bottom. So if you're still missing this idea, it's just a pattern thing. We have the same pattern for what's on top and what's on bottom. We do not have the same pattern for what's on the left and what's on the right. Sometimes this is on the left and right, and sometimes this is on the left and right. It changes pattern right here. So I do not want to do it in terms of y, because I'm going to have to split the problem into two. Everything below here, everything above here. Y is by far the worst way to do this. Also, it's not shells. If you're using y, you're using cross sections. Okay, so we should have immediately in this problem had dx, we should have had 2 pi, we should have had 1 to 5, and that was without thinking. Next, we have to fill in the pattern. Okay, so we need the pattern for how far is it from the axis of rotation to the edge of one example shell, and that's x. Again, even if you're confused on this, every time it's the y-axis, it's x, and then it's the height. Okay, so the most common mistakes we saw, first off, there were some mistakes where just somebody did something dramatically different. That did not get many points here. But the most common mistake is errors with the radius. Some people said x plus 1, which would be true if you was going around an axis that was 1 unit further over, which was wrong. Some people said x minus 1. I think they were confused by this 1 here. But the 1 is already accounted for right here in the bounds. The rate does not change the radius. That would make the radius too small. In fact, if it was x minus 1, you'd be rotating around this line. Okay. Anyways, then we need to approximate. I did see more errors here than I expected, and if you plugged in incorrectly, if you had this but did not know how to plug in, there was a deduction. And the most common error I saw was just not plugging in. So I think what happens is people have these formulas on their note sheet, and they go, well, there's a function up here. I'm going to plug into that function. But that's not what the question's asking. The question is asking you to approximate this integral. The question is not about this function. It's about this. So this is what you should be plugging into. There absolutely should be a 2 pi in your final answer, because you're approximating this. There absolutely should be an x and an e to the negative root x. There should be an x and an e to the negative root x for each one of these. It's a big deduction if you didn't include those things. The numbers were really nice. So you should have had a 2 here, you should have had a 2 here, you should have had a 3 here, you should have had a 3 here, you should have had a 4 here, you should have a 4 here, it's root 4, which is 2. You should have had a 5 here. If you left this off, it was a couple point deduction, because you're not showing you know how to plug in or what you're approximating. You also needed to have these 4s and 2s and 4s. Okay, so do remember, if we're approximating an integral, and you have this formula in your note sheet that says f of x. F of x is the integrand. It's this thing here. It's not some other random function on the page. Okay, hopefully that kind of clarifies. Lastly, so we had this question. We had 2 of these questions on the homework, and people did pretty good, better than I thought on this question. my advice was to label the bottom 0. If you labeled it differently, I could, and you think you still had, I could talk about it. But people did pretty well on this page, so I don't think I'm going to say too much. Ultimately, in these questions, your job is to find a pattern. So you did not have to write this. This was just more explaining. But I decided to let y equals 0 be the bottom. And then I was considering a horizontal slice, and then we're asking 2 questions. At a given height, if you start at this place, so starting here, and then you end up pumping it up to the spout, you're going to end here. And you just think about that being lifted. So you have this thing lifted from here up. We would like to do force times distance. So we have to figure out what the force is of this and what the distance lifted is. That it's a pattern finding mission. So then once again, let's go through this. Okay, the distance lifted. Well, if you're calling this y, and if the distance from the bottom to the top is 3, then the distance lifted is 3 minus y. So if I give you y equals 0.4, if that's where you're starting, and then the distance lifted is going to be 3 minus 0.4, it's going to be 2.6. Okay. Then the rest of the question was, how much does it weigh? Well, it's going to be 62.5 pounds per cubic foot times the length times the width times the thickness. That's just figuring out how much something like this weighs. If someone gives you the density, you then multiply that times how much water is there to get the weight. And this was, the length was 3. They already told me that, so we can fill that in. And the width, that was the hard part, is changing. When you're at the top, the width is 1. When you're at the bottom, the width is 0. There's many ways to find that width. The homework used this similar triangles, which would have worked here. Could you basically say this is y, this is 2, this is 1, this is the width. Similar triangles gives me that the width is 1/2 of whatever y is, which sort of makes sense. You might even be able to see it. When y is 2, it's 1. Oh, it's 1/2. The general technique is to draw it and find the equation of this line. And the equation of this line ended up being 4x. You say, hold on, where's that 4 coming from? Well, it's the slope. But if you have a point on this line and y equals 4x, then what does that tell you? Going back to our labeling skills, it tells you the distance from here to here. So if this is y over 4. But that's not what we wanted. We wanted twice of that. We wanted the width. So we wanted 2 times y over 4, which is y over 2. So there's several different ways of me explaining the pattern for the width. And that's what needed to go right here, times the thickness. So now we've done it. We have figured out that if you give me a slice and tell me where it starts, tell me the y value where it starts, then this is how far it will be lifted from start to end. And this is how much it will weigh, depending on the thickness. Okay, that was that story. Once again, I've done that a few times, but I thought we'd go. So then we're trying to integrate. So then you say, okay, what are we trying to plug into this? So we've got this pattern that says, if you start at this y value, here's how far it's going to be lifted. Okay, so then we have to say, where do the y values start? Well, there could be a y value down here at 0.3. There could be one up here at 1.7. Okay, the y values can be anywhere from 0 to 2. Some people are still mistakenly trying to say 0 to 3, but there is no water starting between 2 and 3. You say, well, what about, isn't it pumped up there? But that's already accounted for in here. Again, the pattern we're finding is based off of water starting at that value of y. So this is always going to be where your water starts. And then this is the pattern for what you're doing with those slices. Okay, then the rest was calculation, and actually people did pretty well with this calculation. I tried to make the numbers come out as nice as I could. Okay, by and large, people did pretty well. If you're missing more than 10 points on an exam like this, that is a little concerning. But you're still doing all right. If you're missing more than 20 points, that means there are several big topics you're missing. You have to prepare. I'm trying to get you ready for subsequent courses. and you need these skills. You need to build up your precision a little bit. So sorry if it didn't go as well as you'd hope. Please watch my other video about grades to see how well you still can do. But hope this is helpful.